So we're talking about the fundamental counting principle, and it is useful for counting the number of ways a series of procedures or events can take place. The key is that the first procedure or event does not affect the second procedure or event in any way. The second event does not affect the third event, and so forth. In other words, each event is independent of the other events. To determine the number of ways each individual event can occur, we're going to multiply all those number of ways together to get the total number of ways the series of events can happen. So if you're in my class and you've watched all of the videos, sorry, Siri came to life on my phone. That last dice problem we just did in 12.1, we took and multiplied the 6 times 6. So that's kind of where we're getting to here. So using mathematical symbols or notation, we can call the number of ways the first event can happen as k sub 1, and then the number of ways the second one is k sub 2, and so forth, all the way to k sub n. So this is kind of what it's going to look like. So we're going to use the fundamental counting principle to count fundraising choices. Recall that the Engineers Without Borders chapter on your campus, so we did this fundraiser in the last section, is raising money to build and install a water purifier for an orphanage in Honduras. They are going to select one fundraiser for each of the semesters prior to the trip. The possible fundraisers are an online auction, air hockey tournament, themed road race, and karaoke night. In how many ways can the chapter select the fundraisers? So this is a problem that we did in the last section, and we are going to redo it using our fundamental counting principle. So if you remember, they had to choose one in the spring, and they wanted to choose one in the fall. So they're going to choose one for each of the semesters. So how many can they choose for the fall is what we're going to look at. So we're going to do the fall, and we're going to multiply it by the choices in the spring. So in the fall, they have 4 choices. They have the online auction, the air hockey, the themed roast, and the karaoke, which is 4. But in the spring, how many choices do they have? Remember, they didn't want to repeat the fundraisers. They wanted to do one this time, and then they wanted to do something different. So that means in the spring, there would only be 3 choices because we're starting with 4, and whichever one they use with the 4 of them, they have to take away the one they used in the fall, and they only have 3 left. So if we then multiply it by 3, we end up with 12. And that's a lot faster than what we did in the last section where we wrote all of the events out. Pull that up. So before we knew about the fundamental counting principle, we had to write all of the choices out and then figured out there were 12 ways to select it. Now we can just take the 4 times the 3 and equal to 12. So it can speed things up a little bit. All right, let's look at example 2. So for example 2, we are going to use the fundamental counting principle in coin and dice problems. So for part A, we want to know in how many ways can 4 coins be flipped? If you remember in the previous section, we drew a tree diagram and figured it out. So we did it the long way. We wrote it all out. We flipped 1. We only did 3, but if we did this problem with it, we'd have 1, 2, 3, 4 coins, and then we could write out all of our solutions, or we could count the ends to see how many ways there are. But actually what we can do is there are 2 sides to each coin, and we're doing it 4 times. So we can just do 2 times 2 is 4, times 2 is 8, times 2 will get us 16 ways. All right, let's go to part B. So we want to know in how many ways can 3 dice, and we're going to call them a red, a green, and a blue, just for fun. So we have a red die, a green die, and a blue die. How many ways can they be rolled? Now we're going to, since they don't mention a side in this, we're going to assume it's a 6-sided die. So if we roll the red one, there are 6 choices because it's 1 through 6. Times on the green would be 6, times the blue would be 6. 6 times 6 is 36, times 6 will get us 216 ways that you could, or combinations you could get when you roll those 3 die. All right, let's look at example 3. Example 3 says that many restaurants in your city are participating in Restaurant Week, when they will offer a 4-course fixed-priced menu. Patrons will order a complete meal consisting of an appetizer, a soup, an entree, and dessert. One restaurant offers 4 appetizer choices, 3 soup, 6 entree, and 5 desserts. How many different complete meal choices are possible at this restaurant? All right, so let's look at example 3. So there's 4 courses. We have appetizers, we have soup, the entree, and dessert. And we want to know how many ways we can order this. So they had 4 appetizers, they have 3 soup choices, 6 entrees, and 5 desserts. So what we're going to do is just multiply those. So 4 times 3 times 6 times 5 will get us 360 complete meals. Oops. So what that tells me is that if we go to that restaurant, I could order my meal in 360 different ways. Now, does that mean they're really drastically different? No. I could order the same appetizer, the same soup, and the same entree, and just order a different dessert. Or I could order the same soup, entree, and dessert, and then just order a different appetizer. So it's only going to change one way, but it's still, you have 360 different ways that you can choose from your choices. So you can make your meal 360 different ways.